call upon Mr. Manu Nair, CEO EtherealX. We have Mr. Nair here in the guys. Ms. Saraniya, Vehicle Director, Agnikul. Mr. Liwaans, Amuthan, Founder and CEO, Cosmicport Space Technology Private Limited. And George Weinmann, developing new space he's a strategic and venture consulting Challenge Aerospace. I request George to kindly moderate the session as well. Over to you, George.
Good morning, everyone. I think we're going now. Good morning, everyone. My name is George Weinmann. You may have known me from my previous role at Blue Origin, where I was covering the Asia-Pacific region. I have left Blue Origin and I am now operating separately, doing strategic advisory work and investment development. Looking forward to bringing new capital into the space industry. But that's not the exciting thing we're here to talk about today. We're here to talk about our colleagues on the stage who are really developing the next generation of launch vehicles and technologies that are going to make them bring new industries to succeed in the space industry. So what I'd like to do is start off with just brief introductions from each of them. As we get going, I think it's worthwhile to note that we're in an unprecedented era of technology development in the space industry. There are, obviously, everybody's watching the news with Starship. We have later this year the first launch of Ariane 6, which I hope for the Europeans will be a success, at least technologically. And then Blue Origin's Liwaans rocket is expected to launch in the third quarter. That'll also be a dramatic new development, particularly because few people know a lot about Liwaans. It's not as well known as some of the other rockets being developed. But a lot is riding on that particular vehicle with the NASA's Artemis program and their plans to return to the moon. In addition to that, you have a variety of other players in the United States, Europe, Korea, Japan, and here in India, as well as in Australia. And so many of them are smaller launchers. Several of them have ambitions to become bigger. What's interesting to me is that not all of them are taking the same technological path. Some are, and some are not. And so it'll be interesting to discuss today in the technology discussion what technologies are robust and which ones are going to be new and game changers for this industry. So with that, we'll start to my left and then go across the stage. And everyone, please bear with me a little bit because I am taking on this moderator role on short notice due to the weather outside. We've had some delays, and unfortunately, our original moderator could not join us this morning. So with that, please give us an introduction of what's new with Agnikul, because I think we all know who you are. But tell us a little bit about what you do, and then specifically where things are in your technological development.
Myself, Saraniya. I am working in Agnikul Cosmos. Recently, we had a suborbital vehicle launch and was seeing the effect of the suborbital. We also got it sorted because we were trying to demonstrate all our technologies in that vehicle. So, to start with, in our Liwaans sorted itself, we tried to bring in some new element that is basically printing of our vehicle. So, our engine is completely 3D printed from the complete truss chamber with the injector, igniter, everything is a single phase technology. I think that brings from the timing, the new technology we are implemented. So, already outside India, there have been many 3D printed engines. I think the only change is that it is integrated as a single piece, which brings down the time for assembly which is required. So, if it is in multiple pieces, we have to go for the assembly integration time, which is involved. So, that is one innovation. I think now even PSLV phase 4 also gets a transfer of the engineering work. Then I think the next is coming up is the mobile launcher. So that will also help in speeding up the launches. because our concept of this mobile launchpad is basically we'll be able to launch wherever the requirement is. All you need is a launcher which is mobile. You can take your vehicle wherever it is required through the mobile launcher. I think that is another technology which we are working on. Then regarding the, I think these are the two technologies as such I would like to start.
So that's a great introduction. Tell us a little bit about what's going on. We'll come back and probe some of these details a little bit. Let's move to one of our new ambitious, not so new, you've been here for a bit, but probably one of the new ambitious rocket concepts for reusable capabilities. Tell us about EtherealX and what's been happening.
So I think that I think it's been precisely about 26 months since we've officially started off with our development program. But unofficially it's been roughly 32 months. And the fundamental goal for us is to achieve absolute reusability in launch vehicles. I think for us the goal was to make sure that every single, the fundamental challenge was to ensure that every single component that we developed was towards reusability itself, and that has been a primary challenge for us even in the phase of engine development. So we've done in attaining also the concept of absolute reusability, which we'll obviously have to fly for us to really know. But at least for that, we've done what's not done in the last 40 to 50 years. We've introduced a completely new rocket engine cycle that allows us to re-enter our pursuits in a way that's never been done before. But I think we are on the right track for now. The math works, the engineering works. So I think the flight will determine whether or not the technology will be an efficient one to use.
I'll just let you go into a good introduction.
Hello everyone, I am Liwaans, CEO of Cosmicport, and I have my co-founder here with me as well. So we are based out of Pillsbury, and we incorporated like 15 minutes ago. So basically we are pretty young compared to all these startups. And our vision is, like the whole vision started with a global, like a green space of starting from the South India, because that is something we thought that was lacking with all the existing developments, the other startup companies. So we are primarily a launcher, a small satellite launcher, and our location is extremely close to the new spaceport that's being constructed over there. So our business model and target is kind of focused to the cruise spaceport. And we make a two-stage orbit liquid engine, purely without space. The reason why we went to methane is primarily because we wanted to have the green propellant in our product. And it was interesting when we first started seeing the space ecosystem over here. All the existing companies, or like the startups, like people had their own specific or like a product focus or like innovation technology that they were trying to target. And we kind of really stuck onto the green side of things, because that kind of would be the next thing for any human spaceflight or reusability or even interplanetary missions. And we do know that it's kind of a hard take in terms of technology development when it comes to designing a cruise engine. But we thought that should be our next focus, especially with this developing space part and the space where it's happening. So that's our primary model or like the technology side of things. And our team is currently working on hard fighters since we're pretty early on that, and we are hopeful that we'll achieve the next milestone when it comes to the liquid metal engine design. And we also do sustainable satellite solutions. That's a very customer-driven product model, and we are working on satellite plus integration designs for synthetic aperture data technologies. And we have a US subsidiary as well, which is primarily to assist this satellite division. But our primary product focus is small satellite launcher. So that's Cosmicport.
So this is a good introduction. I'm sure many of these companies are already familiar to you. So let's dive into some challenging questions. I'll start with EtherealX. So you talked about reusability. What do you think is going to be the hardest thing to convert your initial vehicle from a flight demonstration into something that actually is reusable? And I know you're trying to do both first and second stage reusability, but let's start with the first stage. what do you think is going to be the thing that convinces you that the first stage is in fact going to be a reasonable?
For the first stage, we are not sticking to one particular mode of deceleration. We have combined two methods of deceleration of the booster stage itself. Primarily because we want to save a lot of fuel when we are doing that, and that directly affects our payload capacity or weight penalty. So I think where the one way to look at it is obviously the last bit of the suicide burn is something that we'll be first targeting with the hot tests. I think for me to be really satisfied that the booster stage is going to be that, the avionics package and the flight software is something that we're very heavily focusing on. We have an in-house algorithm that we've already developed. And this was before the SN10 flight started. And we mapped, so our algorithm, we mapped it with the SN10 flight path. And we were not even off by a second. We knew exactly at what time the approach is going to be. So we kind of know the direction that we have to do and what's the approach towards landing of the booster stage. But again, there are going to be a lot of physicalities because the trajectory that we have is also, it's very challenging to do a two-stage to orbit from Shri. Because you also have Sri Lanka and Australia coming in. So the trajectory as well as bringing back the booster stage is a little tricky for us to put it in a very optimal spot. But I think I'll be confident once the flight software package is ready for the first stage. But and because we're confident on our propulsion system, the engine side of things. The upper stage, I think we'll not want to reflect because it's very, it's something that's never been done before. I think it's also new for the rest of the world as much as it is new to us. So if we make that happen, then we create history. If not, we still back until we do.
So you opened up a couple of can of worms right there. First, we talked about software, doing things kind of yourself, and then launch support issues. So I want to dive into that a little bit, but I'm going to share the wealth here a little bit. Agnikul is probably the furthest along in terms of actually building and now doing flight tests. What's your view towards vertical integration, doing it basically yourself, soup to nuts, versus collaborating with other industry partners in the Indian ecosystem or internationally? Do you do everything yourself, or do you buy from the supply chain? And how has the supply chain supported you so far?
Sure. So regarding the product, most of the components in the vehicle is in-house design part mostly we do. But there are few, suppose the telecommand system for our vehicle was purchased from DSCC, so that is ISRO. Because developing the telecommand system might take us longer time and prove that the system is going to work, we might have to go one step ahead and prove that it can actually blast when it is there in the flight itself. So those kind of, but still we are planning to develop in later. But for the first and second developmental flight, we are trying to purchase directly from ISRO. There are few components like this which we are trying to purchase from outside. But others, design-wise, we are trying to do it all in-house. But fabrication, we are doing it outside only. For example, if I'm taking the structural parts, the tanks or the skirt structures. So those things only few machines which we have, with which we will be able to make only small components. For the bigger components, we are relying on the outside vendors. Since we are a startup, we have faced a lot of challenges when we are making a suborbital vehicle. Saying that since it's a very small quantity which we are doing, and all the industry outside is expecting a bigger order or a higher end. So those challenges are there, but we have found some reliable vendors who are supporting us, who have been supporting us in our suborbital vehicle too. So yeah, we are trying to develop even with material which is required for our orbital vehicle also. We have started sourcing even outside India, and we are putting in this.
That's great to hear. Supply chain and industry integration is a very important thing. But for a newest player on the block, what's your view towards how you want to build the supporting ecosystem to operate your vehicle? Is it something that you think you're going to be more vertically integrated, or do you think that you're going to depend more on the industry?
Actually, that's a good question for us because our journey kind of depended on this very question too. When we first started being a resident of Tier 3 city, we had to look up all these things. So we incorporated 15 months ago, but like our journey started two years ago, thinking of this very question: how can we bring resources or manpower and even build the ecosystem in those three, which has potential for the coming decades. But then, like to start with, it's a kind of whole new class, especially starting with a space startup in a city with just engineering resources and supports. So in terms of that, we really prefer the horizontal integration at the start, and we still continue to do it for a long time because at some point, like each company will have its own vertical growth, but then we rely and will rely completely, not completely, majority on horizontal integration. So for example, we have a design team working on the launch vehicle configurations, but for example, the extra simulations on vision design, pressure control, we are using ISRO expert support, and we are also collaborating with space labs from XDSSE. So all these people are in assistance, and also in my degree, IPRC. Like all these people are supporting our projects, which will be required because we don't think we can have all the people, or not all the people, majority of the people required to start the R&D work for a methane-based engine. So that's one thing that we see. And even in general, bringing liquid methane to the market, that's the next step. In terms of manufacturing methane, that's process-wise, it's really easy. But in terms of the number of fabricators or manufacturers available for production of methane, that is something we still need to bring into the ecosystem. But I think once we start this, we have other MSMEs floating around, both in Cosmicport and to supporting our processes. Even for instance, in our hot fire test design that we're working on right now, basically all the structures and tests end up primarily designed by the local engineering companies and manufacturing industries that are out there. So we are only trying to primarily source the extreme high-end profile nozzles and things that will require higher-end manufacturing processes to other places like Bangalore and relevant areas. So yeah, it's going to be a huge learning curve for us. But horizontal was like the first thought that came to mind when we first started this company.
So I'm curious, you said you're using methane.
Yes.
So why, as a small launcher, do you think methane is the right fuel? It's often associated with people who want to do large rockets or reusable rockets because it burns clean and so it leaves the engine relatively pristine. But for a small launcher, and I think you're disposable, but are you planning reusability in the future, or is this using methane a stepping stone to bigger emissions?
That's a perfect question. So one of our potential specs is partial reusability of the first stage or the booster stage. So we did a 3-month market study just to see the trend of where it's heading towards in terms of propellants and configuration wise. So when we saw different players, for instance, Agnikul, like Saraniya was saying, they're focusing on 3D printer technologies, and semi-cryo and Skyroot has a combination of solid and stage liquid propellant. And we saw what is the next trend in the small satellite market, and this was a continuous discussion with like multiple SIA experts, and then we also saw what US was doing in terms of their small satellite launch vehicles, specifically military space as well. And the main thing that we saw was configuration is one thing because Indian ecosystem has a spectrum of launch vehicle products, and what is the niche that we are trying to bring. And developing Metalox engine kind of opens up multiple things like interplanetary human space flight and specifically reusability because we need the liquid engine start to have usability of the first booster. And that was one point. And then in terms of bringing methane into the picture, we have to start at an early stage because it is going to be super costly for extremely small launcher or its launch vehicle, and that's why we kind of sized our payload space around like 600 kgs for an expendable mode and around 300 kgs for reusable, so we can have a reasonable cost-effective configuration as a business model, but still start doing this methane propellant in the upcoming space parks that's being constructed. So it was a mix and match of decision making, and we strongly want to stick onto the reusable side.
So I have so many questions because I think one of a few small launchers that's planning usability. We have Rocket Lab is just now beginning to demonstrate that, but after a long time of operating as an expendable rocket. It's interesting. I'm not sure how many people in the audience know this, but Blue Origin's new Shepherd rocket, which is suborbital, operates with LOX hydrogen, which was a very odd choice for a suborbital rocket because hydrogen is very complicated to use, especially on a small scale. But they did that intentionally because their ultimate goal was to go to the moon, harness the lunar resources, and be able to use the water ice on the moon and turn that into propellants. And so they wanted to start with their very first rocket to build that experience of working with hydrogen, so that when they eventually build the landers that go to the moon, they want to operate with hydrogen for a long time. So your choices at the very early stages do make a big difference in terms of your experience and capabilities down the road. All two of you at least have mentioned software as a critical area. So you were talking about a little bit in development of your systems, and then you mentioned the need to outsource that and purchase communication systems and the underlying software that drives that as part of your development path. In our offline conversation beforehand, you were giving me an example of some of the analysis work that you're doing and how to build something from the ground up. Can you comment a little bit about India is known for IT and software engineers and that capability generally, but in the aerospace industry, do you have the depth of field to get what you need in terms of software development? And while you think about that, I'm going to give two examples. In the United States, two major programs, the Boeing Starliner and the Sierra Space Dream Chaser, both were significantly delayed because of software issues. So software is often the unspoken critical path item in aviation or aerospace operations. So with that in mind, and the fact that you had some difficulties buying off-the-shelf analytics to do what you would do, tell us about your experience. And you can give the example if you want, but I really want you to talk about the depth of the industry and whether or not it needs to go to the next step.
In my opinion, right now within India, it's very difficult for us to just independently outsourcing software package for at least usable launch vehicles. It's almost next to zero, the availability of the same. So the closest that we can get to, because we're looking at almost 10 million, 20 million lines of code, right? When we're looking at an entire package. Now, it is not fully possible for us to develop all of that in-house. We require a good amount of resources in doing that. But the way we are looking at it is that we are developing that capability. We have one or two field engineers who are working, will be working with this particular firm to develop this in-house. So you can have a base template for the entire package redeveloped, and then you can have the specificity based on your mission be coded by your in-house team. So that's the way we are looking at it. But there's going to be 100% involvement of our engineers in the development process, primarily because there is not enough, or there is no availability of off-the-shelf software packages for this to happen. It is one of the core challenges that we are fending off right now. And I can very confidently say that this will be one of the most challenging issues for us even as we move forward until we do at least 2 or 3 flights. Because not only you can have the most accurate data points from the real-time atmosphere data, whatever it is, but at the end of the day, until your booster stage, even for the first stage for that matter, has really done 2 or 3 flights and re-landed, you will not get enough data points to successfully, let's say 100%, feel say with 100% confidence that my next flight is going to strike a properly landing without any software glitches. So it is going to be a challenging aspect for us. But in the case of the second stage, even more so, particularly when we are talking about entry through the ionosphere, there's going to be a good amount of challenge that we'll be also facing there with the onboard flight computers. So we are keeping all of that in mind from the beginning. But to answer your question, in my mind, I would say right now we don't have readily available capability within the industry for us to do this. But I think that's one of the reasons why Agnikul had to develop a lot of it in-house, while they were able to get a few of it outside, but most of the stuff had to be in-house for us to do.
So there are, in other parts of the world, similar problems, and a number of companies have now sprung up to solve these kinds of solutions, to provide simulations, to provide avionics solutions, and to be available to the industry. Now, some companies have decided not to partake of that and go vertically integrated. Others have spun out of companies. So there are a few companies that spun out of SpaceX because they had to develop this capability in-house and then realize that they could sell that to others. Does the international market, do some of these things that have been happening in the United States and Europe, I don't know whether or not Japan or others have offerings, but does the international market offer you opportunities where they've gone through this pain point and they are now creating software systems and capabilities that are helping you to move more quickly? Or do you think that India really needs to build up its own industry in this particular area to support? Or do you think it's a vertical integration solution?
To be honest, when we started our system design, we never thought of purchasing software as a system also. So that is how we started developing in-house equipment, and we have not even explored options outside for general software. Because I feel it is more specific to our system, how we want the data to be or how our packages are going to work. So our software has to be very much compatible with the vehicle which we are doing. So I think that's why we never approach or search for anything outside. From start itself, the plan was to just build.
So now that you're deep into it, and the industry is looking for all sorts of new ways to bring new companies to be entrepreneurial, to provide services, is this an area that you would recommend to the venture capital community, to the entrepreneurs, to the PhD candidates who are about to graduate? Is this an area for them to say this is a need that needs to be solved? Or do you think it remains an internal vertical integration path going forward?
I think for us it is an vertical integration internal path. But as Manu was saying, I think it will be required because many more companies are coming. It don't have to be physical integration. It would be better if there are more companies in India who support the software engineering.
Okay. So I'm going to flip a similar question to the other side. So given that there are many people looking to come into this industry, some 200 startups now, that potentially that becomes 2,000, where do you think, rockets are sort of an apex of vertical integration, I should say, integration of many different capabilities. Fueling systems, you mentioned, launch pads, the manufacturing, analysis software, operational software, telemetry, all sorts of different things have to come together into one integrated package. What's not out there in the Indian market that could be for the right group of entrepreneurs that would support you and others in the industry?
I think the first thing would be definitely the software packages that you're saying, and that's kind of a not extremist nightmare, but it's not something that startups are easily accessible to when it comes to getting robust tools. For instance, you need to design tools like your SolidWorks or CAD-based tools, and then for simulation you have these ANSYS-based tools. They are extremely robust tools for industry standards, but even if you compare, like say, Indian market or as opposed to like other nations like US and Europe. They come up with similar pricing for even startup packages, where you still get a few sets of features, but it's priced to a very high pay point. So that has always been an issue. So as a company, as an early stage company, again, we try to do a lot of things on the coding side, and then we would try to schedule the systems with limited tools. On the other hand, one thing that you mentioned on the international collaboration, so we have the Spain government reached out to us for this circuit and control software, which is currently being used by ISRO, spaceflight program, and a few others. And again, we don't have the capacity to get something like that, but they really narrowed down, like lower the price point, so they can start the startup ecosystem, like doing this collaboration branded along with these new companies. So that's one thing that happened for us. So we would say like there's a starting point for these, new entries of these heavy tools to come into the startup ecosystem. But other than that, I think developing proprietary tools is also required in terms of security as well. So the other thing that's something that startups ecosystem needs is the security aspects. That's because it is a defense and space sector, and then we do see that we have limited security resources that we can have it in affordable packages for the company, especially where in a startup it's kind of chaotic and you have multiple things happening at the same time. That is definitely something we need to see develop. And the third thing is specifically for our location, we definitely want to see like multiple MSMEs grow around the locality, because not just government banks, even if we need to have some integrated design modeled and fabricated, we have to find the right resource that has the quality as well as the lead time to handle the requests from flexible startups basically. And definitely the test facilities, which are kind of spread out across the country, but that is kind of a slower based infrastructure code. But at least the first three are basically the primary concerns that we have as a startup, and hopefully it develops over time, and it should.
Okay, so I'm going to put you guys on the spot here a little bit. When Agnikul started many years ago, the industry was not like it is today. But now things are accelerating. Do you feel that you can move faster today than you could 5-10 years ago? And so if you can move faster, then give me some dates. What's going to happen next? Give me a prediction. And when do you think you exit the development phase and enter the operational phase?
Sure. Regarding the development, I think government has also taken a lot of initiative. So right now the body in space, which has been created for private sector to interact with ISRO and take data. I think that has helped us a lot. That has definitely accelerated our work, and it was not there definitely 5 years before when 8 years before when we started this. And also there were no more investors at that time. I think that has also been improved a lot more. And since I said about this space committee, I think they have focused a lot in suborbital vehicle to interact, to get big from ISRO. We have got test facilities when we get there. So, and we actually launched a Shri. So even all the interaction, everything happened through space. So it became a little easier because it is more standardized and systematic. This will definitely help us to accelerate our work. Regarding the timelines, I think maybe in 2 years we are seeing that we can develop a model.
Okay, so you marked it here. So it's June 28th. So 2 years, midsummer of 2026, we're going to be flying rolling. Okay. So how about you? When do we get to our first hops? When do we? You're still in engine mode now, but tell us what your timeline looks like.
So we will be testing our product limited engine by August. Once we do the repeatability tests, like we were speaking earlier, the 925 will not be very far with the approach that we take. 925 mm engine of the booster stage, that will not be very far. So once we have that ready, so our target for now is to have our first launch by 26 quarter 4. So that, and we're looking at an orbital launch itself, but of a smaller vehicle. Primarily because we want to first verify the software packages. That will be just a simple configuration of 125 km in the user stage and 440 km on the top. And we can, in the test vehicle, we can go over 1.2 tons. We're also working with certain folks from outside of India on the insurance segment, but we're also aligning it with the new NGP in Spaces product. On the larger, the full vehicle front, we are looking anywhere between 27 quarter 4 or 28. Because in this interim, we are also doing clustering. So the test bed itself involves clustering of 440 km engines. But the larger issue is clustering the thrust chamber of the booster stage. Because you're looking at, we have almost 80 degrees with a 925 km in all directions. So that's going to be a primary challenge, and we are already working on that front. So, and as for the hot test, like you mentioned, I think by next Jan you will be seeing a hot test of the answers.
Okay, so do I get an invitation? Sure. Okay, so you talked about launching from the Israeli side. In the United States, people love to go to airport and watch the launches or even see the tests. Even standing out, not on the launch site, not at the Cape itself, but from the towns nearby. It's become a thing, right? To go and watch launches in the United States. Europeans have to go to Peru, which is a little hard to get a flight down there. What do you think in India? Is it going to become a thing to go and watch a launch? Is it say, do the facilities enable popular culture to be part of the launch experience? I think that's give me your view.
I think it's already begun. I think even today there is possibility for you to buy passes and also launch. But I think it's going to now we are in the phase where remember the golden space era where you had the entire country being excited about all the launches and anything that has flew in space. I think India has been going through that now, and we will, I think, continue to be in this momentum in the next foreseeable future as well. So since we have right now another launch pad also coming down South Tamil Nadu, I think it will be fantastic opportunity for most of the public to really go and see. And as far as Shri, I remember the first time I saw the launch pad Cape Canaveral, the Falcon 9 itself. It was sadly I have not seen the GSLV or the PSLV launch yet, but it was fantastic experience for me as well. So I think this culture has been already on the move, and I think it will continue to develop over time. I think the entire country is excited about this.
So should I open a hotel next to the launch site? How about down south? Does the new facility, is it set up in such a way that the public can be part of this experience? I know there's a range safety issue, right? You can't have people too close. But is it in a location where people can come and watch?
Okay, so down south, so right next to the ISRO spaceport, so the Tamil Nadu government has invested a lot on a huge spaceport. They're doing it in clusters. But the whole point is to not just develop MSMEs, but also have the social infrastructure to promote the entire space activities. And definitely the south needs more awareness as well, like way down south. And I'm pretty sure like once the construction and everything comes into place, so I think the timeline right now seems to be 2 years in terms of finishing the launch pad at the least. So definitely I think it will be a new thing for people down south to go look at the space launches. Because I think Shri has become a mainstream place, and the South needs to bring up all these new excitement to the space launches.
So we have here at this conference our friends from Australia, and there are about a dozen different sites in Australia that would love to be a future international launch site. A few have more momentum than others. Have any of you considered going to a launch site outside of India? And if so, why would you consider to do that? So I'll start from that and then we'll work across.
So you mean like a preferred launch site?
Well, for those who are aware, India's launch sites are constrained, right? You mentioned from Chicago, you have to watch out for right, and who you're going to fly over. And down south, you really only have one trajectory, which is south over the poles. There are other markets outside of India, but there are also different geographical situations for range safety and for where you can fly over or even what trajectories you can fly to. So, have any of you considered a possibility of launching outside of India? And if so, what would drive those decisions? Or what would be attractive to that decision?
Okay. So when you say launching outside India, I know primary constraint for country-based products like launch vehicles which come under defense, you kind of are restricted to your nation. So in terms of cost, like India still seems like a lot to play a place for like not just manufacturing, but also launching a launch vehicle. And in specifically the small launches, so Cosmicport does seem like a very preferred spot. But in terms of reusability, I would really appreciate the landmass that's available in the US. And I think some aspects reusable too, but the reusability aspect, we still have to figure out what is it. If it's a vertical thruster and return booster entry, then you need a huge landmass or like a barge ocean-based landing system. So it's not the same geography as what United States have when it comes to like huge barren lands. So that would be my preference purely for reusability. But we also try to make the geographical setup that can work for the legal ecosystem as well.
Okay. I think we're trying to keep the panel short today because of the little bit of late start. But just really quickly, your view from a reusable rocket point of view and launch sites. Would you get here in India or would you consider international?
We are evaluating both options actually. Even right now for the full scale vehicle, we anyways have to build a new launch pad within Shri because the current launch pads are not designed for such a large vehicle. Though we are already in the process of initiating towards building a larger launch pad along with ISRO. We are also looking at other options to parallel launch pad. Because when you look at it from a pure commercial standpoint as well, there are also other fantastic sites that you can utilize. So you don't necessarily have to be a polarized launch vehicle, you can be a multi-polar operator. So we are evaluating on options.
So I'm going to cut us off there because I think we're trying to get back up on schedule. So thanks everyone for joining this launch discussion, and I'm sure we'll see many new technology developments. And you all become famous for the things you're pioneering in the industry here in India. So thank you very much, and I'll hand it back to our program.
Thank you very much for such an insightful session. We have a felicitation ceremony as well. May I request Mr. George to kindly felicitate panelists. Manu, Nair. Ms. Saraniya. And Mr. Liwaans, Amuthan. I request Agnikul to kindly felicitate your Weinmann. And we can have a group picture as well. All of you together. Thank you very much. Now we move on to the next session. It's on the defense space, achieving third space capability to launch on demand on high altitude platforms. And for the same, I would like to call the chair, Lieutenant General Panellists, former Deputy Chief of Interior Defense Staff, Mr. Periyasamy, co-founder and CEO Galaxy I, Ms. Saraniya, Vehicle Director, and Mr. Shri, Saraniya, co-founder and CEO, and Drugs Private Limited. So the panelists of the next session, I think probably they might be outside the hall. So within few minutes, we'll start with this session. Apologies for the delay, and we'll be very quick. We'll go and come with the permission of the chair. Padma, sir.